Good afternoon. My name is Jason Johnson, amateur radio operator Kilo 3 Juliet Sierra Juliet. Today I'm going to be giving a presentation on behalf of Bowie Wireless Association, and the topic is going to be digital mobile radio. So here's my contact information. So I'm going to be recording a couple videos and posting those to the BWA Google Drive. But for today, I just want to give a introduction video on kind of the why behind DMR radio. So why is there been a move to look at this technology, and why is it gaining popularity? So one of the drivers for the need for digital mobile radio is improving the spectrum and utilization, as well as there's some enhancements that DMR offers to the radio themselves. Regarding the spectrum, to typical 2-meter or 70-centimeter analog FM, the channel for one user is 25 kilohertz. And in areas where there are quite a bit of repeaters, there needs to be coordination to make sure that there's not interference between adjacent repeaters. With DMR, the bandwidth required is actually only 12.5 kilohertz. So this is a reduction of about a 50% reduction in bandwidth just from the RF side. The other advantage of this is if there is an area where there's density in terms of existing repeaters, you can actually pick areas where there's gaps and kind of fill in the coverage there. Another improvement that DMR gives is a 40% improvement in terms of the amount of time that your transmitter is operating. And this is due to what DMR does in terms of recording the user's voice. So with analog, it's a FM, it's a continuous waveform that transmits whenever you're speaking. When there's audio, there's a signal going out. DMR, on the other hand, will sample your voice with using like kind of a sound card if you're used to a computer, and it will transcode that information into digital bits that get transmitted on the RF channel. And it's not always transmitting, which we'll see here in the next couple of slides. So one direct improvement to this is improved battery life. So you can have a battery that lasts longer, which leads to a better experience for the operator. And then the final area which I want to cover is there's improvements that digital mobile radio brings in terms of coverage area over traditional analog with 2-meter FM or 70-centimeter FM, for example. And beyond the improvements to the spectrum and the radio, there are improvements for radio operators themselves. The first area is you can think about when you want to talk with someone, you have to be in close geographic proximity. So this may be a simplex frequency you'll use on 2 meters or 70 centimeters, which would be relatively local. A repeater allows you to extend that coverage to beyond a broad geographic location. And with repeaters that are networked, you can also further enhance your ability to communicate. The advantage with DMR is that it is a digital mode, and it supports bringing the coverage that you have anywhere. And so, for example, maybe you're on a trip and you want to still be in touch with members of your local radio club, K3BWA, for example, Bowie Wireless Association. You can actually bring your coverage with you. You just have to have a local hotspot and connect that up to the internet either through Wi-Fi or an Ethernet connection. The second improvement that this brings is the ability to send short messages over both the APRS network as well as other cell phone users right from your radio. So this is nice in that you can receive APRS, which are packet-based communications, and you can transmit. But also you can say maybe you're out on a hike somewhere and you don't have good cell coverage, but you do have maybe connection into a local DMR repeater. You can send a text message to someone, or you can receive a text message, which is nice. Not all radios, DMR radios support this, so it will depend upon the particular radio that you have. But the short message service is a nice feature for operators. And in addition, radios also have global positioning system for position reports for APRS. They have Bluetooth modules, so you can actually operate hands-free in your vehicle. And finally, some of the DMR radios are both dual mode, meaning they will do analog and digital DMR in the same device. This is beneficial that you can keep kind of one radio for both analog and digital coverage and stay in communication with those that may still be on analog. So what I want to talk about now is the bandwidth consideration for DMR. On the screen in front of you, you'll see a kind of a channel that is 12.5 kilohertz wide. This would be a narrowband FM channel, for example. And as you see, the bandwidth is along the kind of horizontal axis, and then along the diagonal going into the page is time. So with an analog FM transmission, the power is being used and the signal is being transmitted for the entire conversation. Also with this, you only have one user on the frequency at a given time. Maybe I will be talking to someone, so my conversation will go to a repeater, for example. Then I will stop talking, and then the person who wants to talk with me starts, and they fill in the entire spectrum. DMR, on the other hand, is slightly different in that same frequency, the 12.5 kilohertz, it is broken up in time. So we have the red time slots, which can be used by one user. And then there's also a blue time slot, which can be used by another user at the same time. So I say at the same time. It's not directly at the same time, but from our perception, right, we can't tell the difference. So DMR will take my analog voice into the microphone. It will digitize that and encode it into a data stream that's about 30 milliseconds. And that 30 milliseconds of time will be transmitted. Then my radio will go silent, for example, and then another user, say in blue, will transmit their 30 millisecond time slot. And then I'll continue transmitting and wait, and they will go, and then I will go. So the advantage of DMR is that you can think of this as having two repeater channels on a given frequency. So that gives you improvement in bandwidth. You can have two individuals served at the same time. In terms of coverage, this diagram shows a graph of the, let me switch this off for a second. This shows a graph that compares the intelligibility of the conversation to the signal strength of what is received, say at a repeater location. So the top curve in green and red would be traditional 2 meter or 70 centimeter analog FM transmission. So as you'll notice, the stronger signals are on the left-hand side of this graph, and as the signal gets weaker, it goes to the right. So at a certain point, say at negative 95 dBm, the FM audio starts to degrade. Now, the degradation is kind of a slow roll-off. So it will start degrading slowly until a point where you will not be able to hear it again. Now we can compare this analog to DMR, digital, in that it's a little bit less intelligible. Some say they prefer analog voice codec over digital. I've used both. I don't have a preference on either. I'm able to make the digital out just fine. One thing that you'll notice on this curve is once the FM starts to degrade about negative 95 dBm, there is no change to intelligibility for DMR. And this can continue until you get out to between 104 and 116. Let's call it 108 to 10, negative 108 or negative 110 dBm. And at that point, you start to have a degradation of audio quality. What that will manifest itself in DMR is you'll start hearing drops in the conversation because it's a little sub-packet, 30 millisecond sub-packet of time that the information is transmitted. And also you can notice that there's a sharper roll-off in this curve. So it does not degrade as gracefully. However, you'll do know that you don't require as much power, dBm, for DMR over the analog. Now what does this mean in practical terms? So the next slide is a capture of a conversation I had with another local operator, Doug, KC3VJS. And on this diagram, we were making a call through a local DMR repeater, N3LHD, which is in Upper Marlboro, Maryland. With the website that this is documented on, the Delmarva DMR, there is a link to a device called a C-bridge. And a C-bridge is just you can think of it as a device that routes the voice conversations of digital mobile radio. And there's several rows on this diagram, and you can see the first is my conversation that I was having, and the signal strength that was received was about negative 112 dBm. That was the received signal strength. Also, you'll notice in the first line there was a loss rate of about 5.7%. So with that particular signal strength level, a 5.7% loss, I'm about 8 miles from this repeater, and I was sitting in my home about 8 feet from the window. And I think I was running medium power at the time, so I wasn't using, say, 7 watts. I think it may have been between 3 and 5 watts in the repeater. One difference from my location is I can't reach one of the local analog repeaters at the same distance. So clearly I'm making it into the repeater. There is a little bit of a loss in the communication. The next row is the communication from Doug when he was talking, and he had slightly better signal strength. There's a negative 105 dBm. And notice that the loss rate was only 1.8%. So this corresponds to the diagram that we saw. About 104, right, to 105 is, a 1% loss isn't too bad. And the other couple things they're on here I will kind of talk about in the future slides. So beyond making communications through a repeater, you can also make communications through a hotspot. So what I have here on the diagram is a Raspberry Pi Zero that is actually running a digital DMR hotspot by a software called Pi-Star. And the way it works is I have my radio and I talk to the hotspot through my radio on a simplex frequency. There's only one antenna on this particular hotspot, so when I transmit from my radio, it goes into the hotspot, and then the software will take that information and package it up and send it out to the internet over a Wi-Fi connection. So the advantage of this is you can bring your own coverage anywhere you want to be. You can actually connect this up to a local fixed Ethernet connection. You can have a Wi-Fi connection. I've also used APRS beaconing for a recent simulated emergency test where I connected my hotspot to my cell phone. These hotspots are low power, anywhere from 20 milliwatts to 100 milliwatts. And in the particular picture here, I'm actually sending APRS message. I'm sending a position report, my GPS coordinate, over the DMR network, and then it gets routed into the APRS.FI network, and that would be plotted on a map. So this concludes some of the background of what are the drivers for DMR. So in summary, some of the reasons that drive for DMR is improved RF utilization, improvements to the radio to include better power utilization, as well as there's some improvements in the coverage. You don't need to have as much signal in order to have intelligible communications over DMR. And finally, there's some advantages for the user, which I've kind of covered with the hotspot to bring your own coverage. You have services such as short messaging service to send messages to APRS or other cell phones. And in my next video, I'm going to be going over some of the details that explain the technical aspects of digital mobile radio. So thank you for watching, and if you do have any questions for me, my contact information is on the first slide at the beginning of the presentation. And I hope that you'll watch the next video. Thank you very much.